Well, hi, good morning. Thank you so much for joining me in my shop here for another run on this radio. Today is November 25th, and apparently a big snowstorm is coming a few days from now. That's what all the weather reports say. So we're all ready here for it. The last thing I have to do is fire up my snowblower and make sure it operates before I find out when it's too late. So this radio. Yesterday I got sidetracked with a problem that showed up with a open resistor I found down here. Fixed the resistor, thought I'd just give the radio another chance to work entirely. I put this temporary capacitor in here to reconnect the volume control output. And nothing came out of the speaker. And if you're wondering what my plans are for that speaker, once I have other things sorted out here, I'll return to the speaker and we'll see what we can do about it, because I certainly haven't written it off as impossible to repair. It is possible, although not very likely. So I'm going to get back to what I was doing, which was going after these two capacitors down here, after struggling to even identify them. First one I want to go at is the same one I was ending off with yesterday, which is the capacitor. Oh, what was I going to say? It's the capacitor that carries the signal from the triode here to the output tube there. And I think I did a voltage test. I'm going to start with repeating the voltage test. We'll do the before and after thing again. And let's do that right now. Do it right now. Okay, now also we're not listening to this radio because the speaker's not producing any sound and I don't have it connected to the soundboard. So we should hear nothing from it. And let's get ready here. Okay, on the 500 scale, checking for B plus at the, there it is, 150 there. And 200 there. And we're feeding the radio with 100 volts, so 100 volts coming in. This is a little low too. Now we'll take a look for voltage on the input side of the capacitor, which will be right down in here. So this is what the capacitor is trying to hold back. I think on the schematic it says 65. Let me get this on here. So on this reading it's 60. So it's holding back 60 volts. How much is it holding back? We'll find out on the other side. Can you see the meter come up a little bit? Just a little bit. So we'll put this down on 5 volt scale, full scale. Let's see if it goes full scale here. So 2.5 volts, positive. Now there should be a negative voltage on the cathode. Cathode, which one was the cathode? No, not a negative voltage on the cathode. That's the wrong way to put it. Should be a positive voltage on the cathode. Ooh, that sounds like a cat fight. So we have 3 cats here, in case you don't realize it. 2 new kittens and an older cat that's been on its own for 6 months. And the older cat is not happy about the new cats. And so consequently when they get close together, the old cat constantly says, "You stay away from me." And it does that by growling and hissing kind of quietly. So, and it hasn't changed. And so we're not so hopeful that she's going to change her way. Now what am I doing here? I'm looking for, I forgot totally what I'm doing. Oh my god. Well, I've only started the coffee. I'm not very far into the coffee yet. Well, I was going to look up something. Yeah, darn cats. Distracting me all the time. We were going to look for the cathode on the 6A6. Perfect. Okay, cathode is 8. I could have known that. I could have known that. 8. Now, my flashlight with a brand new batteries in it. 8. Okay, so we're looking for a positive voltage, small voltage on this pin of 50 volt scale here now. And doggone it, I lost sight of it. So on the 50 volt scale, we're looking at 10 volts. On the 15 volt scale, it's about 10 volts. So you have about a 10 volt bias set up, and we're eating 3 of it away, 2 or 3 of it away with the capacitor leak. So ultimately the bias on the tube, the grid to cathode bias, is going to be something like 6 volts negative. 6K6, let's look up typical operation. With 100 volt plate voltage, you would expect grid number 1 voltage to be -7. That's roughly what it is. Interesting. And yes, they're back. Oh, there he goes. The house is being terrorized here. Yeah, there he is. Oh, here comes the other one now. So these two guys are brothers. I don't know if I ever mentioned that. I didn't realize that they were brothers from the same kitty litter, cat litter. Huh. Okay. And back to chewing the wires and doing all that stuff. Well, I try not to step on them. Watch out. There's nothing here to eat. Don't eat anything. Okay, so what does that mean? That means probably the bias in the tube is acceptable at the current situation. Turn this voltage, supply voltage up, everything's going to go up a little bit. Arguably the bias would go up a bit and the leak would go up a bit. You might end up in the same place as now. But certainly there'll be a small improvement if we do the capacitor, and I better turn this off before I forget and stick my fingers in there. Okay, so we'll replace the capacitor there. Okay, so I've replaced this capacitor just now, and the next one I want to go after is not on the schematic. There's a capacitor that runs from pin 3, the plate, around to pin 8, which is the cathode. So I don't know. I guess I'll just replace it with, what size is it? These guys don't have their size written right on them. Wow, I don't have too much to go on here for what to do. Let's cut it out and take a look at it. It's much easier to replace. This last one was pretty tough to get in there, but this one's quite easy. There it is. Why do we give these two guys a test? So this one that's in my hand is the one that's a bit of a mystery. This is they look exactly the same size. Let's give this guy a test first, the mystery capacitor. Very awkward here. Okay. So I have to assume this is a capacitor intended to reduce harmonics that come out of the output tube. That shake in the camera just there was a cat pushing the tripod leg. Okay, there we go. 50 volts. What do you say? Popped right open. That popped open suspiciously fast. Let's try next voltage up. That's really too fast. Let's try another one. So that's indicating it's not connected. Either these clip leads didn't grab, or there's something wrong with this capacitor, or it's really tiny, which I can tell by looking at it. It's the same as the 0.01. This could just be an open capacitor. Okay, I think I'm on there. Nope, still doing the same thing. Yeah, I'm pretty sure this is just an open circuited capacitor. And this was the one that conveys the sound from the triode preamp to the grid of the output tube. Let's see what this one does. Well, that's more what I would expect. The eyes just close right up. It isn't even going to open. So I think both these capacitors are bad for totally different reasons. Okay, we're going to test the other one on my smart little tester here. So yesterday I received some information from, or I noticed something about how YouTube was operating with payments for me. I'd make a little bit of money at this, of course. It's a little bit. Something didn't look right, and when I looked further into it, the American government has decided to tax me 30% here. My first inclination is quit. I'm not doing. I pay Canadian taxes on my meager income here. And now I'm being forced to pay a large 30% tax to the United States. Now it's a withholding tax. I don't know what's going on. Never, it's a complicated situation. If you're a video maker, you're in a country outside of Canada, the situation is complicated with taxes. And but Canada has an agreement with the United States over this. So we've agreed that each won't tax the other parties, the other country's citizens, in this kind of situation where you are in one country but you're actually earning money from a company located in the other country. So we have an agreement that we won't cross-tax each other. So I report my income to the Canadian government and pay taxes there, and even though the money has come from an American corporation, it doesn't matter according to the agreement, and that's the way it's operated for 10 years until last month. Last month was my record income month. I never earned as much money as I did last month. Almost twice what I normally earn. I don't know why, but it happened anyway. And I'm not talking about a huge amount of money here. I'll tell you what it is. It's $500. I earned $500. I was beside myself. But now the American government has come in and whoosh, taken it. It's gone. So I don't know what to think of it, but I'm close to quitting. Let's just put it that way. And I'm going to keep that to myself while I sort this out, except for I didn't keep it to myself. I ended up blurting it out here on my channel. Because the fact is, I couldn't even sleep last night. 10 years. 10 years of this. And now? So, okay, damaged part, just as suspected. Or no part. Okay, so what would I put in there? I mean, I'm just comparing the two. The one I know is a 0.01. It's got to be a 0.01. So I'm going to put a 0.01 in there and not fret over it any further. And for the moment, I'm going to go calm myself down because I got thoroughly upset here now. I'm terribly upset about this. Okay, those two are done. Now let's pick another one. Ignore this one for now. Might as well just do this one next. Maybe we'll look at these two. Well, this is grounded here. This is actually a ground terminal. here. So this would really go with the, let's find out what this one is. This is coming from, well, let's see. This is a 2.2 megohm resistor. That's in the AVC circuit. AVC voltage coming here through the resistor, and this goes to ground. So this is the AVC capacitor, I guess we could call it that. We'll look at it on the schematic here in a minute. Take it off there. And this is so I don't forget where it came from. And this one's going to the grounded terminal here. Just doesn't want to quite make it. There we go. Okay, so again, this is, well, I guess it says 0.05 there. 0.05 400. There's a number 507 on it. Probably a part number, something like that. Should we test this? What is it? I didn't look to see what this was. I also didn't clip this on, because I know it's the ground. I do know what this is. This is the AVC capacitor. Hello. Yes. Okay, this guy can go in here. When I first started making these videos, I always showed the work I did up close. And right now I'm not showing it up close, I'm just doing it. I had to stop doing that. The main reason was, one day I was sort of reassessing everything, and I realized I was spending an inordinate amount of time replacing parts because of the video effort. Getting cameras positioned, and it was slowing me down, and a big hassle having the camera. Usually get the good camera view is exactly the same view I need, and the camera's there. So I stopped. I stopped regularly videoing everything I do in here, but this stuff, this one went pretty quick though. Thundering sound is two cats running around on the floor above. There we go. Probably should test the radio after this. That'll be three things I've done. Now, two of them are down here in the audio output tube area, and we're not listening to that. We're going to be listening out of here. Well, who knows? Maybe we'll hear something come out of that speaker, but no, we won't. 0.05. Well, we should test this. I'm going to not do it, but I should do it. Now the front end of the radio appeared to work quite well, and that would include, I think, this. This would be the AVC capacitor, so that would be included. So we can't expect this to be a short. Okay, here we go, 50 volts. What do you do? Well, it's not going to open. So it's as leaky as any. It's leaky enough that You can't judge its leakiness because my testing device is at its limit. Okay, good, so that's already in. Yeah, let's test the radio. I think that'd be a good idea. Okay, I'll get that together. Okay, getting things together amounted to just plugging this in. So I'm going to turn the volume up on my soundboard over here, and we're going to hear with the radio off. Nothing. Okay, that's good. What I'm checking for there is hum and stuff like that in the way things are connected. Now it's actually surprisingly quiet, but this is going into a line input. It's not over on the soundboard. It's not going into the microphone input, so that's probably why. So let's put this in here. You know, I'm going to turn that volume up just in case any moment something should happen. Okay, the volume is down, not that it should matter, and the soundboard volume is right up. There's nothing. Wow. Okay, here we go. We're powering it on here. Oh, what about an antenna? Oh, yeah. I'm going to get an antenna together here. I'll have to stop. Okay, we're ready. So, antenna's connected. Output's connected. Volume's down. Doesn't matter on the soundboard. Volume's down. Up. Down again. Power on. Volume up a little bit on the soundboard. I think this was pretty loud if I remember right. Got my hand on the volume control. Don't know what band it was left on. Gotta put some lights in this radio, Jim. So we're running with 102 volts on the power cord. We're waiting. Okay, those are cats. So apparently I didn't have the soundboard volume high enough. Okay, let's tune around a little bit. What's happening? Ooh, that's not very good. Okay, volume on the board down. Make sure we're on the broadcast band. There we are. Oh yes, now the volume's much stronger. So basically, it sounds like dead short wave. So that's 860, the French station. Don't know what that heterodyne interference is. I don't usually hear that. Just listening to it. Badly distorted. Let's raise the voltage here to its proper.
Peut-être complet partout, il y en a qu'on souhaite.
115 volts on the radio now. Still sounds distorted to me. Judging, let's see, I've got a patter over here. So we pad it. Ooh, I knocked it right out. Okay, I'm surprised. Oh, okay, the patter only works on the microphone. Okay, we can't listen to music. What is that weird thing? That's my pacemaker. I do not have a pacemaker. I'm joking. There's that weird interference, the pacemaker interference, and a station right there. You are, right?
Describing these protests with kid gloves because there might be one person there concerned about the plight of the people of Gaza. I'm done with that. There are more than enough people.
Yeah, he's done with that. Well, that's good. Good for you, whoever you are. Thanks for letting us know how you feel about it. Okay. And I'm not trying to make a comment on what he was talking about. I'm commenting on him. Okay. Where are we down to now? We got this capacitor, which was, I thought, potentially the silencer. Hey, let's try that out. Let me just turn this up.
The other way around. They don't become nice because you're nice.
Okay.
You become
Throw the
nice
switch
to
and
people because they are
click in this
nice to
capacitor.
people. Well, that's the rule I'm playing by now. Because I'm tired of
Wow.
this.
Wow.
I am tired of this. This is not who we are. This is exactly who we
Well,
are.
that didn't do much.
This is what Canada has become. We are, our strength is, what is it, our differences is our strength.
Yeah.
Is all I'm seeing.
Okay, I'm going to turn him off. We need to be wary of people who found out that they can make an income by getting on something, podcast, radio station, somewhere, and just saying upsetting things. And they can make money. And the more upsetting, the more money they make. And oh my God, we've polluted our journalism, something terrible. Not so much here in Canada, frankly, but when you listen to a journalist give you the news, there is no emotion in their voice. It's deadpan. That's the way the news was presented back when I was a kid. Didn't matter what station you tuned in, American, Canadian, British, didn't matter. Deadpan presentation of the news. Just the facts. Here you go. No emotion. But now, I would suggest the moment you're listening to somebody and you realize that they're speaking to you about news and stuff like that, and there's emotion wrapped up in their voice, like there is in mine right now, click off. Goodbye. There are still good journalists out there who speak without emotion and don't try to twig your feelings. So, okay, enough of that. What do we do now? Well, that's a good question, because it sounded a little distorted to me, and I don't think there's any capacitors really left. Just this guy. His brother tested really good. What is this one doing? Why don't we find out what this guy's doing? He's hooked up to pin number 1, 2, 3. Pin number 4, which is on this green wire coming up here to a high value resistor. Green wire. I don't know what he is. So what pin did I say? I forgot. 4. 1, 2, 3, 4 on. I think that's the SA. Yes, it is. Pin 4. So we'll look on the schematic and find out. Pin 4 on the 6SA. So here it is. Pin 4. There's the key. 1, 2, 3, 4. Now, this has got to be the guy right here. 0.05. A screen grid silencer. Yeah. So we should probably change this just to be sure that it's all there. But I'll bet you we'll cut it out and find out it's good. I wonder if I can cut one leg, measure it, and stick it back on if it's good. I've almost never done that. Let's take a look at it. Okay. Ooh, Jimmy. Whew. Radio was on. Can't say I was totally conscious of it. Let's pull this out. Okay. This guy. He could be desoldered and reconnected. I have the feeling this is a replacement. And it'd be really easy to desolder it. Let's give it a go here. If I can desolder one leg, put the test on it. If it tests really good, back in the radio it goes. I wish I could read the value of it, but it's hidden underneath. Okay, just waiting for the soldering iron to come up. So you should never have your hand below the soldering iron. That's a lesson I learned a long time ago. This is really twisted in there. Let's see if I can keep it. Yeah. Let's try this here. There's more than enough wire here to cut it too, even if I really wanted to. Okay, I think we can get that out of there. No, we cannot. See why I can't just yank this guy out of here. Let's cut this. Whoa! That went fine. And we're going to pull the wire out here. There we are. There he is. Out in the clear. So first thing we're going to do is measure it with this guy, because it's easy to do. In case you're wondering how I pick which leads to use here, you don't have to do that. You just pick any two and turn it on. The machine's smart enough to figure everything out. No unknown or damaged part. Oh, that's a little surprising. That's very surprising. That's not at all what I expected there. Let's take it off this one too. You know, if this is a replacement, and if it did come from somebody's junk box, it could have been kind of a, you know, an old man to begin with. Yeah, you see, it wasn't even looped around. So this is a replacement, because there's no way a factory would do that. 0.05 Duranite, made in the USA. It looks great. Let's give it the test here. You gotta start wondering, like, how does this radio even work with all these crap capacitors in it? Well, we did hear some distortion, right? Don't really know how this one would cause that, but okay. Oh, it's turned off. I'm gonna warm this up now. Okay. Here we go. Well, that looked totally normal. That looked completely normal. 150 volts. That looks perfectly good. I'm getting a perfectly good. Well, what happened on the other tester? Let's give it a moment to drain the charge out. Then we'll try measuring its capacitance on here. 0.05 is here. And the scale to get there would be this scale. So we'll go there. And we swing this control until the pi opens. Right there. It's right on 0.05. But it's not opening all the way. I'm not sure. That might be reflective of the condition of my tester more than the capacitor. So how come the other one didn't test it? Let's just give it a moment here. Test it again. I don't understand why the other tester. Hey, what's up there? Lots of stuff. Okay, Testing it again. Maybe the tester didn't make contact. The test leads maybe didn't make contact. Let's try it again. Just work the connections a little bit here. Okay, I'm going to try a different lead. Maybe one of my test leads is shot. Well, 58 nanofarads, that's nothing. 58, no, that's right, that's 0.05. Got a bad lead here. The yellow one appears to be a bad lead. Oh well, nothing like testing the test, eh? Okay. So we took out a good capacitor. Should I put it back in? It's just a 0.05. It's a great big honking thing. I'll put it right. I happen to have one right here. 0.05. Yep. I'll put this one in. So this is gain. Set is off. Everything's safe. Here we go. Oh, didn't you mark where it came from, Jimbo? I thought I was looking at it there. Oh. Okay. I failed to mark exactly where it came from, and there's no nubbin left. And I need to be certain about things. Okay, I gotta sort that out. Well, let's see if this got rid of some of the distortion. Okay. Just like to clean things up a little bit before I energize something on the bench. Okay, I think we're good. Good to go. Okay, the volume on the soundboard is at 0. Headphones. Put on my headphones. Okay, there we go. Power on. I've got to do the light bulb. Let's see what I've got here. That's all. Too high a voltage. Okay, volume up.
Negatively affected by the Canada Post strike, so it's leading to increased costs, capacity issues. We are within days.
Could be a little more volume here.
The entire
No, you can't tell.
season for Canada Post.
I know how high I'm raising the volume.
Canada Post itself will have a giant backlog.
How about the
to sort
distortion?
through, even if this is settled today.
Yeah. Now that there are alternatives, and I want to tell the listeners that I've been an advisor to a company called Trexity.
Definitely
It's an Ottawa
couple
startup,
odd
last mile
distortions in
logistics
there.
company that allows small
Let's try
businesses
tuning.
to offer same-day local delivery, and in order to compete with the Amazons of the world. But that they by no means can shoulder the entire load of Canada Post. What is a small business to do if?
Yeah, in Canada there's a postal strike, a nationwide postal strike going on right now. It's upset everybody, including the people on strike. So
Most consumers have shifted away from Canada Post in a big way, but for small businesses to this point, they are still big in 3 different areas. One, I just spoke to a business owner in Montreal who said that he's got a ton of money from small business clients of his that is stuck in the mail right now. Because still, many businesses pay through paper invoices in the mail and a return check. So cash is one thing, and now he's chasing customers to try to get them to pay through e-transfer to get the money to them. Second, it's shipping of goods, and to especially in rural and remote communities, these private sector alternatives, as good as they are more money in most cases. And secondly, they struggle with capacity issues. Third, they can't get to some of the rural and remote communities where Canada Post is really the only game in town.
And then
beyond,
go ahead.
and then beyond that, businesses also use Canada Post for marketing. A ton of service businesses send out a postcard to their client list right before the holidays. It's a low-cost way of marketing your products. Come in and buy a gift card. Don't forget us. And that option is taken off the table. Yes, there are alternatives, but every time we go
65,
through this,
exactly
more
right.
and more businesses move away from Canada Post, never
the,
to return. That's why I feel like
plate
this is so
voltage
foolish
of
on the
the
part of the
detector.
union.
Yeah.
Because they're really just wrecking their future for short-term gain.
Yeah, if they get themselves a deal, they're going to come back to fewer people and fewer businesses that actually depend on them.
And look, the federal government is not innocent in this. They've had a completely hands-off attitude with respect to Canada Post, and every time the Canada Post Corporation has tried to do anything to try to modernize or save some money, the federal government said, no, you can't do that.
B
You can't
plus
end
on this
any,
too?
you can't reduce any kind of daily delivery services or
175.
or do it in a more efficient way. You have to keep the same old model. And as a result, here we are with hundreds of millions of dollars in quarterly losses for Canada Post, union agreements that make no sense whatsoever even now, and you have a strike action at
60.
their busiest point in the year. So from a
That's
Canada
okay
Post
too.
perspective and a union perspective, this is disastrous too.
Dan, talk to me about the impact that this could have, quite literally, on the existence of some of these small businesses. I have to think that some of them exist on a razor's edge on a good day.
You got it.
When you factor in the fact that we have not come back from the pandemic, and you factor in...
Well, I noticed that confusion because I have also gone, not just to Toulouse, but to Value Village, and then I thought, well, I'll ask Karen about this, and then I realized, no, wait a minute. So I say,
And then Jared Allen's in your face. You're not going to be as effective, but yeah, kind of up and down the roster. There wasn't a lot of
Hope I'm not wrong about this, but the guy mentioned Value Village. That's a pretty popular operation here in Canada. There's a Value Village here where I live. My understanding is that that's a private for-profit business operated by a family in the United States. And they do make a donation to whoever it is they donate to, but primarily it's a business. And people don't know that, I think. Now, I hope I got it right, because I'm saying this in public. So don't believe anything or everything I say. Don't believe anything or everything I say. Yeah, don't. So what to do here? First, turn the power off before you give yourself a big shock. So I think it still sounds a little distorted now. Is it because of what I'm doing here? This is creating the distortion, taking the signal out like this? Don't think so. So the volume control remains a load on the detector. I haven't interrupted that, although there's no lead coming from the volume control onto the triode anymore. That's just cut away. Maybe I'm missing a capacitor. Let's look and see. Did I miss any? These paper ones, or otherwise. So maybe what we can look for, do a little more voltage checking, and see if we can't find a resistor that's gone out, and maybe causing a bad bias or something on a tube, and that's what's causing the distortion. Don't know. That's it for today, though. Tomorrow either do the alignment more properly on the radio, and then listen for the same distortion. And I don't really know how to pursue it. That distortion could be any one of so many things, including just the tube itself, I suppose. Yikes. Well, let's see what we can do tomorrow. So thanks a lot for watching, and have a great day.